Next session will be session 2, ICT for environment protection and disaster prevention. This session will be chaired by Mrs. Wano. Wano-san, can you hear me?
Yes, I'm hear you.
Nice, thank you. Please.
Okay, thank you very much, Mata-san. Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished participants of ASEAN and ICT IVO Forum. After we listen to some presentation from the first session, we continue to listen to the presentation in the second session with the main theme of ICT and for environment protection and disaster prevention. But before we start, I think we can take a photo session first. Okay, before we start this session, let me introduce myself. My name is Woroindah Widiastuti. I'm from MCIT Indonesia. I will chair this session. Hopefully, this session can run smoothly and successfully. Thank you. In the second session, there will be 3 presentations that will be delivered. 1 from Vietnam and 2 from Indonesia. Well, to shorten the time, I will let the first presentation, Dr. P. Lee Nguyen from Vietnam, to deliver his presentation with the title Realizing Mobile Air Quality Monitoring System Architectural Concept and Device Prototype. Okay, 10 minutes time is yours, Dr. P. Are you ready?
Yes, good afternoon, everyone. My name is Nguyen and I come from Hanoi University of Science and Technology. So, can you see my screen now? I'm sharing my screen. Can you see my screen now?
Yes, we can see.
Yes. Okay. Okay. So, I will start my presentation. Okay. So, today I would like to introduce our project entitled Realizing Mobile Air Quality Monitoring System, Architecture, Concept, and Device Prototype. And this work is a collaboration between our university and Chiba University in Japan. So in this talk, I will first introduce the background of our research and then the problem statement and our goals in this project. And then I will present our solution and some preliminary results. So as you know, air pollution is getting more and more serious all over the world, and especially in developing countries like in Vietnam. And in our country, air quality monitoring is mostly based on static station, and I think this is common all over the world. And for example, in Hanoi, we have about 50 stations in total, and most of them concentrate in the central area. And for monitor air quality real time, we have some application on smartphone like Air Visual or PAME and so on. And this application provide the user the real-time air quality information, and they also bring the forecasted information in a near future, like 1 week ahead air quality information. And the current air quality monitoring system suffer from 3 critical issues. And the first one is the limitation of monitored regions. And because the static stations are quite expensive, so they are deployed very spare. And the monitored regions are very limited compared to the total area. For example, in Hanoi, we have only 50 stations in the total area of more than 3,000 square kilometers. And the second problem is the lack of a fine-grained forecasting and analyzing system. And the current forecasting model can only provide the short-term forecast, for example, within 1 week ahead. And especially all of the forecasting model now cannot predict the air quality in unmonitored region. So it means that they cannot provide a temporal prediction. And the final issue is the lack of public database for developing country like in Vietnam. So in our country, researcher like us is very difficult to access the raw data of air quality information. So in this project, we aim at construct a fine-grained real-time air quality map like in this figure, and we hope to bring a high accurate information about air quality at anywhere and anytime. And we also want to build an API library for analyzing and forecasting air quality using machine learning. And finally, we also investigate the optimal deployment of air quality system. So to realize that goal, so we have two keys in our solution. The first one is to leverage the mobile monitoring system, monitoring devices mounted on vehicles like buses. And by exploiting the mobility of the vehicle, we can broaden the monitored region, and then we can monitor a large region with only a limited number of devices, and we can enhance the prediction accuracy. And the second key point in our solution is to use spatial and temporal prediction model. And by using temporal information, we can forecast future air quality at any time. And by utilizing the spatial information, we can predict air quality at unmonitored regions. And so, I'm sorry. So here is the architecture that we have proposed. So we propose a three-tier architecture, and at the bottom we have sensing tier that consists of many sensors, many IoT devices mounted on vehicles, and this device will collect real-time air quality data, and the sensory data will be transferred to the application tier through the communication tier. And in the application tier, the server will store the sensory data and perform machine learning model to forecast the future trend of the air quality. And we also predict air quality in unmonitored region. And the application tier also optimize the behavior of monitoring devices to provide information to user through smartphone application and web portal. And currently we have finished the prototyping our IoT device, and we also running field tests. Here are some capture of our devices. Here are some sensor in IoT in our device, and belong collecting the air quality of indexes. We also measure the GPS, and we also measure the energy consumption of the devices. And here's the circuit layout of our device, and there are four main components. The first one is the MCU, and we use Wi-Fi and LTE for communication. And for the power, we use both battery and solar energy harvesting. And this is the device and functional blocks in our device. And this one is the sensor module. And this is the operation flow chart from when the device collects the sensory data and send to the server. And here the screen in our server. And this the data stored on the device SD card. And we also run the field test, and we mount a device on a private car, and we run over Hanoi. And here's the air quality information collected from device and visualized in our web portal. So besides collecting the data, we also perform the data calibration to correct the data, the raw data from sensor. And we are trying various machine learning model to calibrate the data. First we try some simple model like EasyBoost, and then now we try more complicated model like GAN, and we use a very high accurate device for reference like GRIN 03 and GRIN 07. And here our experiment setting. And in this slide, I'm showing some preliminary result on our calibration method. And you can see in this finger, the red line is the ground truth and the blue line is our calibration result. And you can see the calibration result quite match with the ground truth. Okay, so in this project, we have proposed a mobile air quality monitoring system rely on IoT device mount on vehicle, and we already finished prototyping, and now we are collecting and calibrating data and put them on the web page. We are welcome on collaboration, and if you have any question, you can reach me at this email address. Thank you very much.
Okay, is there any question regarding her presentation? I think there's no question. So thank you very much, Dr. P, for your presentation.
Thank you very much.
Okay.
Excuse me, there are questions. People have raised their hands.
Okay, I didn't see that. Okay, thank you. Okay.
Thank you. Yes.
Yeah.
Thank you. I think this is an interesting project. I would suggest that you should include use case when you do the proposal. Also, maybe try to include stakeholder into your project.
Sorry, I could not hear your voice clearly. Can you repeat your question?
Sure. It's not the question. It's more toward like I would think that it is a good project, and you include stakeholder into the project. Plus, try to come up with some use case. I think that they make the project look very good.
Oh, thank you very much.
Right.
Thank you for your advice. Yes, thank you very much. Mm-hmm.
Okay.
Could I cut in? Actually, I don't have the icon for the raising hand. I have a question.
Okay. Please.
Okay. My name is Widiastuti. I'm from Thailand. Actually, from Chulalongkorn University, Thailand. We have implement like similar projects, something like this in Thailand. Actually, in Bangkok, Thailand. Actually, we mount on the like a loop bus in Chulalongkorn University.
Yes.
My question is like when your like vehicle is moving,
Yes.
is because of the airflow to your sensor will be different from the stationary sensor. You get what I'm saying?
Yes.
How can you cope with the positions when your vehicle is moving? And then how fast your vehicle is moving. Actually, that is my questions.
Oh, thank you very much. Indeed, that's a very interesting question. So, to get a correct data from sensor, so we perform the calibration on the raw data obtained from device. So now we are perform the calibration on static sensor. But after calibrating on static sensor, we will do the calibrating on moving sensor. So we will make the vehicle run with different speeds, and we will collect also the speed, and we use both the speed and sensory data to calibrate the data.
So it means like you better have like many like static sensors to calibrate like when you're moving, right? How static sensors for you, right? When you have used to calibrate moving sensor.
No, we use moving sensor to like we mount sensor on the vehicle, and then when the vehicle move, we collect the moving sensors data, and we use that data to train our model, machine learning model. Yes.
All right. Okay. Thank you very much.
Thank you very much.
Okay, I think it's time to move to another presentation. Thank you.
Thank you very much,
Dr. P.
Thank you very much.
Oh, not possible to ask another question?
Is it? I think. Is it possible? Okay, please.
Okay. What's your name again? I'm sorry.
My name is Lei. You can call me
Hi,
Lei.
Lei.
Yes.
Hi, Lei. It's quite interesting that you actually use moving sensors.
Yes.
Right.
Yes.
So because if you move the sensors, there is certain limit of speed you can collect the data, right?
Yes.
So how is your project? How is this the limitation of speed? You can still collect the data from the sensor.
Yes, so actually the initial goal of our project is to put the sensor on the buses, and for buses we the speed of buses is not so diversity, so we know the maximum speed of buses. I think about 50 or 60
kilometer.
Yes, kilometer. Yes.
Oh, okay. Thank you very much.
Yes, thank you.
Time is off now. Thank you once again. And maybe if there is any question, you can directly go to Dr. P.
Yes, thank you very much.
Second presentation is I will ask Mr. Hammam Riza from Indonesia to deliver his presentation with the title Artificial Intelligence Driven Disaster Mitigation Solution. Dr. Hammam, please, your time.
Yeah. Thank you. Questions. Ladies and gentlemen, a very good morning to all of you.
Cannot hear you.
We cannot hear your voice.
It's okay. Agak maju, Pak. Agak maju dikit. Sorry, excuse me.
Hello. Can you hear me, everyone?
Okay, Pak.
Yes.
All right. So let me restart.
I think you're on mute.
Thank you so much for Ibu Woro, the chair for attention. A very good morning to all of you. My name is Hammam Riza. Dr. Ilyas from the Center for Disaster Risk Reduction Technology.
Doctor, I think you are muted, or for some reason the sound is very low. The volume.
Can you hear me now?
Yes, I think you may need to stay near your mic because every time you move away, we can't hear you anymore.
Okay.
Yeah.
So you can hear me now.
Yes, we can hear you now.
Okay. All right. So I would like to present our solutions on AI-driven disaster mitigation, and it is done through the Center for Disaster Risk Reduction Technology and AI Innovation Center at the National Research and Innovation Agency of Indonesia. As we all know, some people say Indonesia is the natural disaster laboratory. Since the geography of Indonesia cause vulnerabilities in many regions, which are prone to geophysical and hydrometeorological disaster. We can name all sorts of natural disaster, natural hazards in Indonesia, from earthquake to volcanic eruption, tsunamis, land and forest fire, flood, landslide, and many others. So in doing this, since Indonesia lies in the, I would say, Indonesia lies in the path of most active ring of fire, Pacific, which affects all those countries, Russia, Indo-Australia, and Pacific plate. Certainly, according to the World Risk Index 2020, we can see the risk of disaster in consequence extreme natural events. Most of the world's countries, it is calculated by basis through the multiplication of exposure and vulnerability. Indonesia has the risk of extreme natural disasters about 10%, exposure around 21.3%, up to 50%. So vulnerability encompasses also the societal sphere, and is comprised of also of other components which are weighted equally, such as susceptibility of the structural characteristic and conditions, various abilities of. So at the bottom line, potential disaster in Indonesia can be really grouped in main hazards and collateral hazards. I would like to say a few things about what is the impact of all these natural disasters. Some of the economic loss have been reaching out up to 15 years. For example, the geological disaster from 2004-19 is up to 20 billion. Also, just recently, but South Kalimantan indicated are really suffering economically. Also, from the forest fire here, Bahasa, is also showing up 20 billion in just a single year in 2019, in 2015. So all those are posing a great loss to our nation. That's why in order for us to be more competitive and provide compelling solutions to mitigate this disaster, we adapted to the latest development of technology 4.0, such as AI, IoT, big data, and cloud computing. AI-driven disaster predictive modeling is our way of responding to land and forest fire, for example. for preventing this land and forest fire in our peatland, development of hotspot forecasting system by observing the peat groundwater level. AI-based can be the basis of the policy recommendation on doing the impact-based forecasting and risk-based warning. We are also putting early efforts to mitigate forest and land fires by predictive modeling based on data mining experience. So I want to share with you these two use cases. First, for the land and forest fire prevention, and the other one is start up on AI for tsunami, early warning. As we can see in this slide, the weather modification technology are really an indicator for our action into the prevention of land and forest fire. So it is really a best timing and effectiveness of this operation, weather modification technology, which can prevent the occurrences of hotspots throughout. So in order to do this, we have a several steps of doing AI for forest fire prevention. First, groundwater level for peatland in many provinces are collected. It becomes a big data for forecasting that we are going to put into our time series forecasting, where we do seasonality analysis, model fitting, and evaluation, prediction. Then it will go into the third stage, where the predictive result observation of the groundwater level and the forecasting coming up from different agencies. So the read down station from other IoT sensors in this peatland. So from this, the prediction of the groundwater level in the next 3 months starts in provinces fire mostly occur like in Riau, Jambi, South Sumatra, and other. This will engage into weather modification. So this is hotspot can be reduced and prevented, certainly can be mitigated. The core of this work are data mining coming out from different agencies providing the data. So, for example, the weather data, the peatland groundwater level, and spot coming from ministry. And we also provide this forecast to determine the effectiveness of weather modification. Rate reduction. Time frame 3 to up to 6. The next one is our use case is AI-driven tsunami early warning system. Prone to tsunami because of the ring of fire.
Time up, Pak.
No, there's a lot of tsunami. Same. Tomography.
Master.
Yes. Okay, I'm getting to my last 2 slides. So tsunami modeling along the Sunda and to Banda Sea. We have developed tsunami modeling for more than 1,000 scenario for exercise in South Java Sea, where we are very prone to the collision of the plate from Eurasia and Indo-Australia plate, which can cause the major earthquake in Indonesia. And from this, we build up the modeling, which we call peka tsunami, prediksi kebencanaan tsunami, where we predict the tsunami prediction system, travel time, location, and wave. I think that's all that I can say. Thank you so much for this opportunity. Thank you.
Okay. Is there any question from Hammam presentation?
You can still listen to me, right? Yeah.
Yeah.
Chair, I have a question.
From UTB, please.
Okay, Hammam. Dr. Hammam Riza, how are you? Long time no see.
Hello.
Tony Anwar here.
Hello, Pak Tony. How are you, Pak Tony?
Yeah, I'm
Good to
okay.
see you, Pak. Yes.
Yeah. So, Pak Hammam, can I call you Pak Hammam, right?
Yeah, sure, sure.
I would like to know your tsunami warning system or something like prediction system, eh?
Yes.
How different is this to the existing ones? Because I know that since 2004, since Aceh tsunami, in Indonesia we have done a lot of research and development in this area of tsunami warning system, prediction system, and so on. Can you inform us, please?
Sure, sure, Pak. Thank you for the questions. So you are right. Since the great tsunami in Aceh and in the Indian Oceans, yeah, there have been efforts to actually provide tsunami early warning system. So at that time, we have worked together in collaboration with many donor countries to support the availability of buoy system. Yeah,
right.
These buoy systems are being deployed throughout Indonesia. Around 22 or 24 buoy system were being deployed, but unfortunately, from time to time, this buoy system were lost or broken. It was really a sad news for all of us since these buoy were being vandalized by, a lot of ships passing through this buoy, and by 2016, we lost all of this buoy system, unfortunately. So starting in 2018, we were hit. Yeah, we were hit by the Palu and Donggala tsunami in Sulawesi. So the government, the president, Joko Widodo, have declared a new development for the tsunami early warning system. So BPPT was mandated by the president to work together with the BPPT.
Yeah. Okay, the difference is the voice system, and now you have AI driven.
We're rebuilding the system, and we have deployed many other buoys.
Right,
and also, we are going to include the Indonesia cable-based tsunami meter, the subsea cable, fiber optic cables, which is equipped with the pressure sensor and ocean bottom unit to read out the earthquake and the potential tsunami. And now the data being collected for the modeling of using AI and machine learning.
Thank you very much, Pak Hammam.
Thank you.
Okay, bye.
I think it's time is already up. I think I have no opportunity to open the question and answer for this session for Pak Hammam. I think if there is any question, so you can deliver directly to Pak Hammam itself. Okay, thank you, Pak Hammam, for your presentation. I think Sarah, the secretariat will announce something. Is still?
Yes, I would just like to ask our colleagues in Indonesia. The problem does seem to have largely resolved itself, but I believe you're all in the same meeting room. So for the following presentations, please remain near the mic, and if it is possible, we would ask that you turn the volume up, because we are getting a lot of dropping out in the middle of the presentation. So thank you very much.
Okay. Thank you. Okay, thank you, Shara. So, okay, let me start for the third and the last presentation in this session. I will ask Prof.Dr. Imas Sukaesih Sitanggang from Indonesia to deliver her presentation with the title of ML-PEAT, or Machine Learning for Data Analysis of PEAT Swamp Forest Monitoring System. Professor Dr. Imas, please, time is yours now.
Thank you very much, Ibu Woro. Can you see my slide, Ibu?
Yes, we can see.
Okay, thank you very much. So my voice also clear, ya, Ibu?
Yeah.
Okay, good morning, everyone. So my name is Imas from IPB University. So I'm going to share our research work and also research agenda. This is the collaboration work between IPB University and University Putra Malaysia and University Teknologi Brunei. The title is the Machine Learning for Data Analysis of Peat Swamp Forest Monitoring. So as the background, we know that the forest and land fire in Southeast Asian region is the big issue almost every year, especially when it occurs in the peatland area or the peat swamp area. We have the data like this, about 70% of peatland in Southeast Asia is occur in Malaysia, Indonesia, and also in Brunei. Especially in Indonesia, we have about 70% the total peatland in Southeast Asia occur in Sumatra, Kalimantan, and also in Papua. As you know, when the fire occur in the peatland, so many negative effects of this disaster, especially in the transbound wage, can be felt by a friend in Malaysia, Kalimantan, and also in Brunei Darussalam. So, in order to minimize the negative effect of forest and land fire, the prevention is the important key there in Indonesia, Malaysia, and also in Brunei. So, this is the idea of our work. So, we need to have the real-time monitoring system, the prone area as. Pardon?
The slides are not moving.
Okay, but now moving in, yeah, it's moving, Dr. Rina?
It's still in PPT mode, but not in presentation mode.
Okay, so, oh, sorry, so I again share the presentation. Okay, so can you see my presentation, Dr. Rina?
Yes, but it's now in slide 3, but it's still in presentation. But I think it's okay. Just present it first.
Okay. Yeah. So, yeah, sorry for the issue. Okay, so this is the idea. So we need to have a real-time monitoring system on the prone area in land, especially in order to develop the early warning system of the forest and land fire, especially in peatland, in order to minimize the negative effect of peatland fires. Actually, Indonesia, Malaysia, and Brunei we already implement the IoT technology in order to record the data in the peatland under the project NRPC, Network ASEAN Peat Swamp Forest Community, funded by ICT Virtual Organization of ASEAN Institute and NICT ASEAN IVO. So in this project, we established the IoT technology in some area in Malaysia, Brunei, and also in Indonesia in order to collect this kind of data, including the water level, temperature, and the humidity in the peatland or peat swamp forest. Okay, in addition to this technology in Indonesia, we already have the peatland real-time monitoring system. We call it the Sipalaga, as Dr. Hammam mentioned. Sipalaga is the real-time system to collect some parameters in the peatland area in Sumatra and also in Kalimantan. Since 2080, the Sipalaga collect the data from 142 devices across into province, to island Sumatra and Kalimantan, using the technology of GSM, and so GPRS to send the data from the land to the server in the BRG in Jakarta. This is the dashboard of Sipalaga. This report the daily data from the fields, including the weather data and also the water level in the peatland area. So in Brunei already implement the IoT technology to collect this data from the peatland. This is the architecture that developed by Brunei. They already implement 4 sensor in the Badas peatland area in Brunei Darussalam using the LoRa technology. This is the architecture. And in Malaysia has already implement the IoT in Raja Musa Forest Reserve, Selangor. They established 6 sensor in this area with LoRa technology. This is the data collected from this technology. This in the right hand, we plot the data from the Sipalaga for since 2080, and this is the data from the IoT system from Malaysia. The issue raised data is about the quality, whether the data has this kind of the issues such as the missing value, noises, and also outlier, and also inconsistent data, because some devices in the remote area Sumatra and Kalimantan are not working properly, especially in the area in the forest and far from the city or from the remote area. So this is the idea. We have the real-time system to collect the data from the land, and then we want to develop the application to analyze and to process the data. So then we will implement the machine learning algorithm to develop the time series prediction model to have the forest and land fire vulnerability. So this flow is to develop the peat swamp forest monitoring.
I'm sorry to interrupt.
Yes.
Your slides are not advancing because you're not sharing the slideshow. So you're sharing just the regular Microsoft PowerPoint window.
Okay. So, can you see my slide now?
We can see moving. Yes, okay.
But okay. Sorry. Is to develop the analysis for the peatland fire data, and then the second one is to forest and fire, especially in peatland. Additional of food, of course, in some publication and also some works to out. The estimation, we also implement the machine learning algorithm to the fires by the computation neural network, LSTM, and also using the Facebook Prophet, the algorithm. We propose this work for 2 years. Yeah, in the first years we want to develop the data preprocessing system, and then the second year we form the forest vulnerability based on the PITS data. This is the contribution. So in terms of innovation, to propose the web-based and mobile application for time series prediction of and which is the third between Indonesia, Maduna, we plans between there is also student included in the project. And then the last one, we want also to establish the cooperation between the stakeholder in Malaysia, Brunei, and Indonesia, including with BRIN. Thank you very much. This is the research team, yeah, from Indonesia, Malaysia, and Brunei Darussalam. Thank you very much.
Hi, Miss Chairman. Could I ask the question? Could I ask question? Could I ask a question? Yeah, what kind of sensors you use for monitoring the peat swarm? Actually, in Thailand we have a similar project that we would like to implement for the disaster management. Okay, but I would like to know what kind of the sensor you use, and then how many sensors you use, right, in order to do the prediction model. Okay, yes.
Okay, thank you very much, Prof, for the question. So I also invite Dr. Wida here to provide the answer from Brunei side. From Indonesia, we have the sensor as many 142, Prof. The sensor located in Sumatra and Kalimantan to collect the weather data, and also the ground level data. Yeah, but the communication we use the GSM. Yeah, and the GPRS technology. So please, Dr. Wida, add the sensor system from Brunei. Thank you.
Yeah, so for Brunei, we actually implemented two sensors. One is for the groundwater sensors, as well as the weather sensors. So we actually planted 3 at the moment, especially around the area where it's degraded. So these are the data we're collecting is basically on the water level, soil temperature.
Could you turn on your camera, Widiastuti?
Judging from the sensors you deployed, do you think that you get a good prediction model actually? I mean, in terms of the number of sensors, and then do you satisfy with your prediction model?
I think because at the moment, the data will be collected from 3 different countries, and it's more viable, and it's more the data is more robust because we're now taking from 3 different parts of 3 areas where the data are more. We have more data, and especially in Indonesia, they have more data, right? And I think in the context of prediction, Dr. Imas will be able to provide more info on that. Yes, Prof. Imas, please proceed.
Thank you, Dr. Wida, from Indonesian side, because the sensor is located in 142 locations, and this record daily data. Yeah, so it's more than enough to do a prediction, because this established since 2080 until now. The sensor still collecting the data, so we have a large data to do a prediction model.
Okay. I think there is Pak Tony Anwar from UBT.
Sorry, okay. I would like to ask you about how many sensors actually do you deploy? You in Indonesia, you said 142 locations. Is it the same for us or is it different? So the second one is what kind of prediction model actually is being used for this prediction result, prediction, predictive analysis. Okay, thank you.
Thank you, Prof. Tony. Yes, in Indonesia, about more than 100 sensor located in Sumatra and Kalimantan, especially in front
Okay.
forest and land fire area, in Sumatra and Kalimantan. As we know, from Sumatra, so many in Rio, for example, Sumatra Selatan, Southeast Sumatra, and also Jambi, in Kalimantan, West Kalimantan, Pulang Pisau, and also in East Kalimantan, so many location.
Because of the forest fire,
Yes, of course, Kalimantan and Sumatra especially. But currently also forest fire is occurred in Papua, but the Sipalaga cover only 2 islands, Sumatra and Kalimantan currently. And for the prediction, the important parameter from the peatland is water level, Prof. Because from the water level we can estimate the severity of forest and land fire. So we want to do prediction on that parameter, the water level in peatland fire. Because if
sorry. I think there is a misunderstanding. Prediction algorithm. What kind of algorithm are you using?
LSTM, lots of memory, and then also because we already proved the LSTM and Facebook Prophet has the good performance in terms of the time series prediction. We already done on this, so we want to implement.
Also in Brunei, LSTM.
In Brunei, I think currently not in the CNN method. Dr. Wida, please correct me.
Time is up.
Yes, and I would like to stress as well that we are the concern is basically to mitigate. So we are making sure that the area is always wet. So we're trying to mitigate the forest fire from happening. So one of the things that we actually look at, that's why it's very important for us to ensure that the water level is at the optimum level. Yeah.
Thank you very much, Prof. Both of the thank you.
Okay.
Thank you.
Okay. Time up now. Thank you very much for Professor Dr. Imas. Now I think we're coming off the end of the session. Thank you very much for your kind attention to hear all the presentation in this session. And also thank you very much for all presentator which has delivered nice presentation. Hope in the future you will have successfully collaboration. Thank you, and I return the next agenda to the committee. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Chairperson Walosa, and all the speakers